We are going to move into our new unit of transformations. Now, the word transformation itself means change. To transform is to change. And that's what this whole unit is going to be about, changing figures, mainly changing their location. Three of the different kinds of transformations are location changes, and one of them involves a size change. But we're going to start with translations and reflections. Now, first of all, we need some general vocabulary words. An image is the figure after the transformation. And a pre-image, remember the prefix pre means before, is literally our figure before a transformation. Now you might think that's not a big deal, but if your directions give you the word image or pre-image, it changes the way you work on the problem. Now the notation, and we know geometry is full of notation, our pre-image points are always, vertices are always denoted with our capital letters. Our image points are denoted A prime. And we would actually say A prime. So this tells me that I took whatever point A was and I transformed it into A prime. By naming them A prime, B prime, we know what kind of in essence the parent or the pre-image is in relation to the image, because we're going to want to keep everything lined up and corresponding much the same way that we did in congruent triangles. Just as a side note, if you take this image point and you transform it again, you would get a double prime. And that would tell me that I moved the A prime, which had been moved from A. Now, another concept we want to talk about here is line of symmetry. And basically, it's a line which cuts a figure into mirror halves. Okay. And that should make sense to you. A line of symmetry is that line you can fold it along and have both sides match up. So here, this top part would match up perfectly with the bottom. Here I could do a diagonal and it would fold and match up. Here are two lines of symmetries. And an equilateral triangle actually has three lines of symmetry. So you could fold it this way, you could fold it this way, and you could fold it this way. And it would match up exactly. Now, when we talk about transformations, we're going to be talking about the ABCDO of transformations. And you're always going to want to check your ABCDO. A stands for angle measure. And it always stays the same. Now this should feel pretty good to you after dealing with congruent figures. We know the angles are the same. And similar figures, we know the angles are the same in our similar figures. So that one should feel pretty good. Betweenness seems weird. And basically, betweenness is saying that order is preserved. So my figure's not going to be twisted or morphed. If point B is in between A and B in my pre-image, B prime will be in between A prime and C prime in my image point. Collinearity is kind of the same way, is that our points will stay on the same lines. Again, there's not going to be any twists or kinks or bumps in our figures. Distance, we really know, is about length. Our distance may or may not be the same for our different side lengths. And orientation is the naming order. And we'll either name things clockwise, or we'll name things counterclockwise. And it doesn't matter which way you name it. You just need to be able to compare the orientation of your pre-image and your image to determine if they are the same or not. So let's talk about our first kind of transformation. Now the word itself, transformation, is our general category. It's like saying dog, it's our generic. Specific kind of transformation is a reflection. We're going to talk about a reflection as being a flip over a line. Obviously, we're going to call that line the line of reflection, and it's going to create congruent figures. Reflections can be thought of if you took wet paint and you painted triangle ABC and then you folded it in half along K. The mark from pressing that wet paint together would give you the image of A prime, B prime, C prime. So this is our pre-image. This is our image. You see the notation. This is our line of reflection. Now, a couple of cool things. One, when I do this, B to B prime, A to A prime, and C to C prime have a couple of unique qualities. One, those segments are equal with where they intersect that reflecting line, and they're perpendicular, and all three of those segments are parallel. So some interesting, and it should feel good in your gut that if you fold it in half on those on the line, that A would be equidistant to A prime from the fold line. If we talk about our distance, we're going to check our ABCDO. All right, so ABCDO. What happens with reflections in account of angle measure? Well, if my figures are congruent, we know it stays the same. Between this, we don't have any extra points, but if you can envision that I put a point D prime and a point D here, there'd be nothing that would interrupt D and D prime from being exactly on the line, which is going to take care of collinearity, and between the original points. There's no twisting or torquing of our figure. D is a distance. And we can't check the distance directly here. We'll actually check it in the next one. But trust me, in this one, and if by, pictures lie, but if we think about using our paint analogy, it makes sense that AB and A prime, B prime are going to be the same. And we will test it in the next one where we have grid points. And now let's take a look at orientation. Our original is triangle ABC. Now remember, when we do congruent figures, we have to line them up. So that one is going to be congruent to triangle A prime, B prime, C prime. Now let's look at the order. ABC is clockwise. A prime, B prime, C prime is counterclockwise. So orientation is not preserved in a reflection, which makes sense because it's a mirror image. So ABCD preserved, orientation not preserved. So let's look at an example here. If I'm going to flip this triangle KJM over this red reflecting line, basically everything is going to end up mirror opposite. So J is 1 unit from the line, so J prime will be right there. M is 1, 2, 3 units from the line, so it will be 1, 2, 3 units from the line. K is 1, 2, 3 units from the line, so it will be 1, 2, 3 units from the line here. And if you draw the picture, it ends up being an exact mirror image across that yellow or that red line. So we've already feel pretty good that ABC are preserved, but what about distance? Let's check the distance. It's a nice right triangle, so we can count our distances. K to M is 1, 2, 3 units. M to J is 1, 2, 3, 4 units. And if you remember your Pythagorean triple, K to J is 5 units. If you go over and you look at K prime to M prime, it is 1, 2, 3 units, just like we would expect. And M to J, M prime to J prime is going to be 1, 2, 3, 4 units. And K prime to J prime, if we did the Pythagorean theorem, we would find out it is also 5. So distance is preserved. Nothing is bigger or smaller after reflection. Just as an aside, if we checked the area of triangle KJM, we would get 1/2 of 3 times 4, which is 6. And if we check the area of triangle K prime, J prime, M prime, we're going to see that it is also 1/2 of 3 times 4, which is 6. So just another way to look at the fact that between